Assalamu alaikum warahmatullahi wabarakatuh. I have given you three examples last time. One example was the first order linear differential equation, second was with the constant coefficient, and third was with the variable coefficients. And we have applied our method, which is power series method, to solve this equation. Now I'm going to take today an example where we have to solve the initial value problem. Obviously we have the question here which we can't solve by any other method. We can solve it only by with these variable coefficients, and we want to solve it this initial value problem. So first of all, we check that what about the x equals 0, is an ordinary point or not. If it's an ordinary point, then we can define our series about the ordinary point and we can solve it. So we take this example 5. In this example, we use the power series method to solve an initial value problem. This is my initial problem: x minus 1 y double dash minus x y dash plus y equal to 0. And initial conditions are at x equal to 0. So we check this x equal to 0. We can see here when take a2 of x, that is x minus 1, when take x equal to 0, then a2 0 is equal to minus 1, it's not equal to 0. We say x 0 equal to ordinary point. So we can discuss the solution about x equal to 0. So we defined our power series about x equal to 0, that is here y equal to n is from 0 to infinity c n x to power n. We take the derivative because c0 is constant, that's being equal to 0. When we take the derivative, then n is from 1 to infinity. When we expand this one, we get here 2c1, and c1 is our, we're having c1. We take that derivative of c1, that will be 0 because of constant. So our n is from 2 to infinity. So we then take n equal to 2, we have 2 into 1 into c2 x to power 0, that's equal to 1, and so on. So we having y dash, y double dash. We put the value of y double dash, and y dash here, and we get here this equation in this form. Now, as I told you before last time, that if we're having a variable coefficient coming there, then we try to bring that one inside with a function of x. Here is x minus 1, we multiply inside. Here is x to multiply inside, and we modify this our x to power n before we equate the powers. Because here we always, as in the last three examples, we equate the powers and equate the summation. We take summation out and we take power out, we get the recursion relation. And from recursion relation, we can find the general solution. So here we can multiply by x, we get here n minus 2, that become x minus 1, n minus 1. Here is multiply minus 1, which means the same. Minus 1, x is from, n is from 2 to infinity, 2 to infinity, n into n minus 1 into c n x to power n minus 2. So then multiply by x, then x is, this is modified, and we get here n minus 1, x to power n minus 1 into x, that become x to power n. And is from 1 to infinity, there is no change in this one. Now we want to equate the powers. We can see here my n minus 1, I put n minus 1 equal to m. Here n minus 2, we put n minus 2 equal to m. And we put n equal to m, and n equal to m. Now if we get the value of n is taking 1 to this side, m plus 1. We're taking 2 to this side to get m plus 2. Now, so we're replacing here in the whole of the equation, in this term, our n by m plus 1. So we get here m plus 1, then minus 1 become here m, and summation is now changing. When we take n equal to 2, then m is equal to 1, so we get here 1 to infinity. And c is here m plus 1, and then here we get here m. Now here we're going to replace our n by m plus 2, so we get m plus 2, m minus 1. And our summation, when I take n equal to 2, when I take n equal to 2 here, then m is equal to 0. So we get here from 0 to infinity. And then the next term is m is changing our m. So m is n equal to 1, m is equal to 1. Changing this one, we have m, and m is from 1 to infinity. And there is also here m is equal to 0, cm x power m. So we have equated the powers of the function, the equation equal to 0. Now the second thing is we want to equate the summation. As I told you also before, then for example, I am having a y equal to sigma, n is from 0 to infinity, cn x to power n. I told you we can expand it and we can take n equal to 0, we get here c0. Now next summation is from 1 to infinity. So it's very easy to change the summation of our function. For example, I want to change it from 2 to infinity. We take one more term out and we can write this equal to c0 plus c1x. Now our summation is changed from n is from 2 to infinity. It's a very important point. Please mark this one and don't forget this one. Here we change the power and here we change the summation. So you can see here whatever summation here is from 1, 0 is from 0, and here is from 1. From this term, and from this term we take from these two terms, from this term because it's from 0 to infinity, from this term and from this term we take m equal to 0 out. When we take m equal to 0 out, then we get the summation from 1 to infinity. So we have already equated the powers of x to power m in whole of our equation. Now next is we are going to make the equation equating the power of m summation. Here m is from 0 to infinity, here is m is from 0 to infinity, here is 1 to infinity, and here is 1 to infinity. As I said, I take n equal to 0 out, then get c0, then the summation is from 1 to infinity. I take here m equal to 0 out. Now what I'll get here, when m equal to 0, this is 2 into 1 is 2, and n equal to 0 gets c2, is 0 equal to 1. We get minus 2c2 from this term. From here, I get here minus 2c2. From this term, when I take m equal to 0 out, then what I'm going to get, I get c0 x to the power 0, that get here c0. The next term is the same. We take the summation from 1 to infinity now. The next, here we're taking this out, and this is from 1 to infinity, is from 1 to infinity, and here we take m equal to 0 out, we get here 1 to infinity. Now we take the summation out, we are having here now minus 2c2 plus c0 plus, we are having here m plus 1 into m, cm plus 1, and here we get m plus 2 plus m plus 1 is minus sine cm plus 2, and here we get minus m cm, and we get here cm x to the power m is common equal to 0. Now this 0, we can write this 0 is equal to 0 plus sigma 1 to infinity 0. This is 0 plus 0 is equal to 0. Now we equate the power from both the sides to get the value of the coefficients. Now the coefficient of the constant x to the power 0, this minus 2c2 plus c0 on the left hand side. On the right hand side, we are having this value equal to 0. So we are having this is equal to 0. Now we take here the coefficient of x to the power m, and the coefficient of x to the power on the right hand side is equal to 0. Then coefficient is here, we take this term first, minus m minus 2, m plus 1, cm plus 2, because this is the bigger one, cm plus 2, that's why we take it first. Then m plus 1, and then we having here m into plus 1 into m cm plus 1. Then we take minus out, we get here m, and we get here minus 1 cm equal to 0. Now what we do, we take this term to the other side. So we'll get here, this become positive. We get here m plus 2 into m cm plus 2 is equal to, now these terms are m plus 1 into c, m minus 1, and minus here m minus 1 is cm. So we get here 3 terms, 1, 2, and 3. Now we want to find, always when we want to find the recursion relation, then this subscript must be bigger on the left hand side, because this we want to find in terms of the right hand side. So we divide by this coefficient m plus 2 into m plus 1 into m plus 1, and we having here this is coefficient dividing. Now this m plus 1 is cancelled with m plus 1, and this is remain the same. Now we can rewrite our recursion relation here above, and then we start finding the values. Our recursion relation we can just write by cancelling this one. We get having here c m plus 2, cm plus 2 is equal to c m plus 2 is equal to, by cancelling this one, we get here m over m plus 2 c m plus 1, and then you get here minus m minus 1 over m plus 2 into m plus 1, and we are having here cm. What's my m? I am getting value 1, 2, 3, and so on. And we have already get one value, which is over the second last value, this one x to 0, and this value we can write here, that give me the value of c2 in terms of c0, and I can write here this my minus c2 plus c0 equal to 0, and we can solve this one, and get here minus 2 c2 plus c0 equal to 0, that give me minus, I take to the right hand side, to c2 is equal to c0, and c2 is equal to c0 by 2. Now this is my equation, I get the value of c2 here. Now I can have here the second order differential equation. So the arbitrary constant will be c0, and c1 we can contain two arbitrary constants. From here we try to get the value of c3, c4 when equal to 1, we get here c3, and so on.